You probably have an intuitive feeling about what the resistance of a resistor means. It's how much it impedes the flow of current through that resistor. We actually define resistance in terms of, so we call it the letter R. It's the ratio of the voltage applied across that resistor to the current that flows through it. The units of resistance are, if you look at the units there, would be volts per amp, or we call them ohms, and that's the symbol there, ohms. This relationship here is known as Ohm's Law, and that's the relationship between the voltage and the current flowing through a load or a resistor. So what this is saying is that if we apply a potential difference across a resistance of R, a current of size I will flow through that resistor. And if we look back at this equation up here, this definition of Ohm's law, we can see from the relationship between these variables that if the resistance goes up, that will lead to a lower current. Current will go down. They are inversely proportional. And for a given resistance, if we have a high voltage applied across that resistance, a high voltage is a greater push, it means our current will be higher. Those two variables are directly proportional. Some loads, such as resistors, like the one we have up here, obey this law, so their voltage is proportional to their current over a specific range of currents. We say that they are ohmic resistors in that range. And if we draw a graph of what that looks like, and we plot the voltage on the y-axis and the current on the x-axis, we can just rearrange that equation for Ohm's law and say that V equals IR, or I'm just going to write RI in this case. We can say if we have V on the y-axis and I on the x-axis, that makes our resistance the slope. And so what we would see is a straight line with the slope, rise over run, equaling the resistance of that ohmic resistor. On the other hand, for a non-ohmic resistor, these resistors don't obey Ohm's law. So if we plotted voltage against current, we might get something that looks like this. So this might be a typical voltage current graph for a filament lamp, so a light bulb. So as the current gets greater, the ratio of V on I gets greater, which means that our resistance is increasing the more current that goes through. And we can interpret that as an effect, perhaps in this case, as the more current is going through the lamp, it's getting hotter, the atoms are jiggling around more, and so they're providing more resistance to the flow of electrons. So that effect might be due to increased temperature at high currents.